So as you are probably all aware, there was a March 1st, 2019 stipulation agreement that came about after the air permitting issues at the Water Gremlin site. One of the conditions of that stipulation agreement was that Water Gremlin had to enter the voluntary Superfund program as a responsible party-led Superfund site. As the terms of the stipulation agreement stated, they were required to perform a remedial investigation to look for surface and subsurface contamination resulting from their operations. If there is anything found on site, Water Gremlin has to define how much contamination is present and then implement cleanup of that contamination. So as Tim hinted at earlier, we look at a multimedia approach on here too. It's not just groundwater, it's not just surface water, it's groundwater, surface water, soil, sediment, soil vapor, any sort of environmental media that we could have where there is potential for contamination on it. They not only have to look for the contamination that results from their operations, but they also have to determine the extent and magnitude, which means they have to see how much there is and how far it goes. Once that portion is done, they are required to clean it up. In particular, they're required to investigate two primary contaminants of concerns, or two primary suites of contaminants of concerns. They had to look for volatile organic compounds, VOCs. Primarily, they were looking for trichloroethylene at this site, which was the solvent that was used for decades on site as part of their coating operations. And they also had to look for trans 1,2-dichloroethylene, which is the new solvent that is being used as their current replacement coating for their solvent machines. When they restarted, they are continuing to use the TDCE, the trans 1,2-dichloroethylene, but they've also converted a number of the coaters over to a water-based coating. This is it's a mixture of wood rosin and openol and either the volatile organic compound or the water that they spray onto the battery post terminals that they create to coat those and protect those via transit and prevent corrosion when they're in your car battery. In addition to that, we also had them investigate lead on site because, as you are all aware from your interest in this, they are a lead producer. They produce lead battery terminals and lead sinkers on site. So we had them look in these particular media for these particular compounds. So for groundwater, we had them look for VOCs. There was a historic investigation on site in the late 90s that looked at lead contamination in the soil and TCE contamination in the groundwater under our voluntary investigative cleanup program. That came about when they were trying to do some building work on site and decided to do their due diligence and check and see if the soil was contaminated on site with lead, and found some groundwater issues as well too. So we had them look for our VOC suites and groundwater, see what was there and the extent and magnitude of that. Later on, when they were doing additional work, we had them look for 1,4-dioxane, which is one of our emerging contaminants of concern that we look at the PCA. This is a chemical that was used as a stabilizer in certain VOC solvents back in the day. Not as much TCE, potentially TCE, but it was primarily used for 1,1-TCA, which was another VOC that had been used for a short period of time in the past. It's one of the things that we're looking at now across the state and identifying and trying to see, particularly in our closed landfill program across the state. We had them on here. It's a different analytical method than the VOCs. Well, you can find it with the VOCs, but you can't find it down to our health-based limits. So later on, we had them test for 1,4-dioxane as well to get a full site comprehensive view of what's happening from their operations. We tested the soil on site for both VOCs and lead. Surface water was tested for VOCs and lead as well. The sediment, the material within the creek boundary or the stormwater pond, was tested for VOCs and lead. And our soil vapor, the air within the below the land surface, was tested for VOCs as well too. This is Tim's realm of expertise, and I'll defer any questions to the soil vapor portion of it to him. I won't talk with that too much today. That's primarily human health risk. That's about vapor intrusion and soils below land surface potentially coming back up through the building slab and impacting human health. So as a quick explanation of the sample media we look at here, so when I say soil, I mean surface or subsurface soil. If you are a soil scientist, you may cringe at this definition a little bit, as I do sometimes, but it's any of the solid material either at land surface or down below land surface. Could be sand, could be clay, could be anything along those lines. And this can be both outside or below the building. So we have soil samples that were collected on the outside of the facility itself, and also a few that were collected where they drilled through the floor of the facility and looked down below to see if there was contaminant below the building proper. Our groundwater samples, that's water that's extracted from wells below land surface. So those are either wells or temporary wells. That's the groundwater, that's the aquifer. It's a real shallow sand aquifer, very narrow in extent here, that discharges likely to the creek that's right there, the County Dish 14/Lambert Creek. this is not a large regional aquifer. It's not a bedrock aquifer at this point. It's just a shallow glacial fluvial outwash of sand and gravel. The surface water that was tested on this were streams, ponds, lakes, stormwater runoff, all that good information, all that material on site. We tested the stormwater ponds on site. We tested Lambert Creek proper. We tested drainage coming from their stormwater collection system coming off the building roof. And then the MPCA did some split samples along with the consultants for this site to test regional lakes in the area. They tested White Bear Lake and Birch Lake and a few other ones for lead in the surface water on here. When I say sediment, I mean solid materials associated with the surface water. So if we're in the creek, it's the mud and the muck below the creek that we're testing on it to, that's held to a different standard than our soil is, and I'll talk about that in a little bit. And soil vapor, that's the gas below land surface. And again, it can either be outside, we can drill down below land surface and take a sample of what the air is between the soil particles down there, or it can be directly below the building to see if any vapors are trapped below the slab. So as a quick timeline, there was a work plan submitted on May 3rd, 2019 for the work that was being done on this. As a cooperative party-led Superfund site on this, their consultants are the ones that submit the work plans to us. They propose investigations that are going to happen on site, and we take those investigations, look at them, and say, you need to do more on this, or this looks good, but please add this. So this is a submittal by the environmental consultants hired by the company, but then reviewed by myself, Tim, Jamie Wallerstead, our manager, and other folks at the PCA. So it's not them going rogue, it is a approved work plan for the MPCA. They initially submitted the remedial investigation summary on July 30th. We worked with the consultants back and forth on a number of issues on what they were saying on there too, and the summary was accepted as final on November 7th. So we posted the draft version of that early on after I had gone through and done my expedited review and sent comments back to the consultants and had it vetted, and then back and forth between them. So there's a large iteration process on this where before that report is final, the one you talked about in your last meeting, that we've had a lot of input back and forth. So as you were aware, one of the conclusions of that report was that there needs to be more work done to determine that extent and magnitude of contamination. So they submitted a supplemental work plan to us on October 4th. As part of this, all the analytical results that are collected in this next round of investigation come directly to me and to the MPCA. So whenever they submit a sample to the lab, the results come back from the lab to the consultant, to the company, and I'm included in that email chain. So I get the information directly from Pace Analytical in Minneapolis, is where they're running their samples. We're actually expecting a draft remedial investigation summary for the second phase of investigations next week. Sometime next week, could be probably not Monday. I don't think anyone's going to be working Monday, but Tuesday through Friday, anytime at that point, we will be expecting a draft remedial investigation summary for the data we've already seen, and we kind of have an idea what's going to be coming through on that. So once that arrives next week, I'll do, again, an expedited review on it, get some comments out, and that'll be available for public consumption probably before March 1st. We'll try and get that out to you folks on that as well, too. So this is a very well sampled site at this point. There's been a large number of samples that have occurred on it in all of our media. There's been samples outside the building for groundwater and for soil. These were done kind of at the same time. Outside the building in July for the initial remedial investigation. As part of the supplemental remedial investigation, there were probes that were put through the coating room in October, and soil and groundwater samples were collected for those samples from within the building proper, and then in December additional samples were collected on the outside of the property, primarily to the cellar where we didn't have a handle on our extent of contamination yet. The soil and subslab vapor samples that were collected, we had a first round for our non-heating season when heaters aren't on and windows may be open in July through October. They collected more samples in December through January, and there's ongoing subslab sampling that's going on right now as part of their restart operations for their VOC coating. I'm getting data almost every day from this from various subslab points that are beneath the floor building and indoor air in the coating rooms itself. Our surface water sampling took place July through October primarily. On site, the stormwater pond, the creek, and then additional samples were collected in September. Those went up Lambert Creek to the northeast, and then, like I mentioned, the PCA collected some samples from region-wide lakes as well to look at lead issues there. Sediment samples were collected on site in July through October, and it looks like my last little bit got cut off there, but every time they took a surface water sample, they also collected a sediment sample associated with that as well, too. So our screening criteria, I'm going to walk you through this real quick before we get into the maps and the results. just to give you an idea of some of the acronyms we use, what sort of risk are involved in this, we have human health and ecological risk, because our screening criteria that we look at on these are either indicative of, is this dangerous to human health, or is this dangerous to the environment, to the benthic invertebrates, to the loons, the swans, the birds that are nearby. So when we talk about groundwater, when we compare our groundwater values, we refer to the Minnesota Department of Health health risk limit that we have on here. This is a human health risk limit, and these are concentrations that pose little to no risk to human health in drinking water. You'll see me refer to the TCE, we call them hurls, because it's got to make it more confusing for everyone. The TCE hurl is 0.4 micrograms per liter. Used to be 5 for a long time and dropped down in 2015, is that right, Tim? So we're talking micrograms per liter, which is parts per billion. Very small levels on this. Our surface water levels we use are called the surface water screening criteria. These are ecological risk and are pretty complicated formula that were proposed by the MPCA first in 2006. They're hardness adjusted, so they're kind of site-specific criteria. We refer to, or there's 3 tiers of these surface water screening criterias. We're looking at the first tier here, which is the most conservative. Essentially, if you are not above this tier, or if your values are below this tier, there's no risk to existing water users, to the animals, to the invertebrates that live there. And then there's a tier 2, which is a site-specific tier, and a tier 3, which is for more complex stuff where we need to do a 6-month or so long report on that. For soils, we have 2 values we look at. We have our industrial soil reference values. These SRVs are human health risks. These are screening tools to evaluate risk from soil exposure. So if you're above this level, it's dangerous for the kids to go out there and start shoving soil in their mouth and eating dirt, as sometimes they do. We also have our soil leaching values on here, and this is also a human health risk indicator, and this is used to evaluate risk to groundwater from soil leaching. Each one of these parameters is different for all of our contaminants of concern. For our lead values, the SRV is much lower. That's 700 milligrams per kilogram versus the soil leaching value, which is 2,400, something like that. It's significantly different. And then the VOCs are reversed. It's pretty high for the SRV, and then the soil, or it's like 11 milligrams per kilogram. The soil leaching value is like 0.0023, something along those lines. So that's the risk for the VOCs, is that they're going to leach through, they're going to work their way from the soil contamination into the groundwater. The lead is the opposite. Lead is relatively stable in soil. It doesn't want to move unless you have acidic waters working its way through, so that's more of a risk that you're going to eat the soil versus it leaching from the soil into the groundwater. For sediment, we use what are called sediment quality targets. These are ecological risk screening tools that were primarily developed for Lake Superior up there, with all the issues on US Steel and all those sites up in that area. And those are impacts to the benthic organisms, the macroinvertebrates that are there. There's a tier 1 and a tier 2. We shoot for the mid tier on these, which means that there's likely, if you exceed that, there's likely a risk to the organisms there. So as a real high level overview on this, we have limited levels of lead upstream from the facility in sediment and surface water. There is lead in the soil on site. We have VOCs and 1,4-dioxane in the groundwater on site. Groundwater is not being used for drinking water. As mentioned, this is a relatively small aquifer that discharges to the creek. And we have soil vapor impacts that are limited to the facility itself, limited to just the building. We've got a ring of clear around that edge. I'll step through some of these individual ones for each media on this. If my map, it's too big. That's all right. So this is our lead and surface water samples that are on here. I use kind of a stoplight designation on here. So if you're above, or if you're red, you're exceeding the tier 1 standards. Yellow means it's detected. Green means it's a non-detect. Lead is endemic in urban environments. It can be very difficult to trace it back to its source, so we have to step out and be able to see what's going on. So as we can see here, there's lead up on the creek right near this housing development there too. That lead is likely not from the facility. It could be from lead-based paint. It could be from other lead gasoline additives, things along those lines, because we have a non-detect right downstream from it, non-detect up there, some up in the pond there, and then detects here. This is the stormwater pond that comes off the facility itself. These are those surface water runoff areas. The lead in surface water that we're seeing is primarily being driven by mechanical processes. So the stormwater pond is collecting particulate matter, collecting lead, which is what stormwater ponds are meant to do. When the stormwater pond gets too full, however, it spills over the boundary and kind of drains its way through here into the creek. So these hits that we're seeing here, this is, point should actually probably be up there in that stormwater pond. it's the stormwater ponds, and then we're seeing the flow path that goes through on this and the surface water, and then we're actually getting non-detects as it leaves the site. So we're not, this is the stormwater pond. It's likely to have to be cleaned out at some point, but it's doing its job. It's collecting these lead. It's just some issues where it exceeds the boundaries here, and then we've got non-detects here and a detect right at the culvert. This one's much brighter. Our sediment values here too, and this is the same issue as the surface water, is lead is very common in urban environments. It can be from house paints, it can be from leaded gasoline that's been sitting there. Lead is not particularly mobile in groundwater and soil. Once it gets into soil, it binds in there, unless you have really acidic water washing it through. So we can see small amounts detected below our sediment quality targets here. Again, on the flow path going through, we see it from the stormwater pond. There's a little bit of a hit right here, right near the culvert. So as a heads up, on the next round of investigation, I'm going to require them to make another sample over on the other side of the culvert to make sure that we're good on surface water as it leaves the site, but we want to make sure that the sediment is either not leaving the site or is in the culvert. There may be a culvert clean out or something in those lines as a remedial action on it. These results are not surprising, kind of what we expected to see. So our lead and soil values on here too, again, this is what is expected. We detected lead kind of across the facility all over the place in low levels. We detected above our screening criteria. This one is a human health risk level. This is that direct injection or ingestion sort of issue on here. We noticed high levels of lead in the coating room where there's potentially cracks in the floor and preferential pathways for material to work its way below the surface. This was part of an investigation back in the 90s, and I believe 1996, when they did some soil work prior to the 1998 Vic investigation on it. So this is where they may have stored lead out here in the past prior to this information. So we kind of find it on site. It's likely pretty common below the building proper as well. So this is 1,4-dioxane groundwater. This is that stabilizer that was used in VOCs in the past. We find it pretty consistently. These are low level. Our HURL, our health risk limit for groundwater for 1,4-dioxane is 1 microgram per liter, excuse me. So we find it, these SB1s, this is the code room area. So we find it periodically throughout here. We do find it up gradient as well, which is interesting. And then we're finding it to the south of the property. So this is a case exactly where we don't have extent and magnitude determined yet. There's going to be additional sampling that'll take place. This is kind of that little loop, ledge down here, that slide that goes into the wetlands, into the creek. So this is probably as close as they can get with this. They'll have to step either closer to the creek or step on the other side of the creek to get that ring of green that we're looking for that extent and magnitude on this. And then the last thing on here is the TCE in groundwater. This has been documented. There's been TCE on site since those Vic investigations in the 1990s. Our HURL has dropped significantly on this from 5 to 0.4 micrograms per liter. So we find it in the shallow groundwater, pretty much on site. This one is right at that 0.4 mark on this. So what we want on here is we've got our greens up on the north. We've got our up gradient greens on here. We've got our south greens, except for this one, so there might have to be a couple more samples that are collected for TCE as well to kind of bound that. So if we talk about the fate and transport of these materials, and I'm going too long and I apologize. As I mentioned, lead is very common in urban environments. It's not particularly mobile in soil. It's more of a physical method. It's the bits of lead that wash through with the rainwater or that blow out as lead draws from the facility itself. Our aquifer is very limited in extent. It pinches out at the creek. Shallows out, it's 30 to 40 feet deep with groundwater, 12 to land surface across that area. It's likely discharging to the creek there. VOCs will degrade in groundwater and surface water. They go through a process called reductive dechlorination, where they go from trichloroethylene to either cis or trans 1,2-dichloroethylene to vinyl chloride, and then to the constituents after that too. This can be done either with biodegradation. For the VOCs, there are bacteria that'll dehalogenate it and break it down in the aquifer, assuming the characteristics are correct. 1,4-dioxane also has biodegradation, but it's a different pathway. But both of them have photodegradation as well, so if they're exposed to the air, the UV light will break those down from TCE and TDCE into the vinyl chlorides and into the constituents from that point. So that's likely our pathway that we're looking at here. We've sampled, I didn't show the VOC samples on surface water here, but there's none in the creek. Obviously it's exposed to the air. These VOCs want to volatilize, go up in the atmosphere, and then get broken down by the sunlight as well on that. So future work that's going to be required here, There needs to be extent of magnitude of the contamination. As I mentioned, we got to get some groundwater samples to the south to get that ring of green for our 1,4-dioxane and a couple for our TCE on it. I'd like a couple confirmation samples across the road for the lead and surface water and sediment. The surface water looks good, but that's ephemeral, as you folks are all aware. Surface water changes from day to day, stream to stream, snow event to rain event, but we do want that sediment on the other side. And then there is a deeper aquifer here that's separated from this upper shallow aquifer by about 40 to 50 feet of clay, low permeability clay. That was sampled back in the Vic investigations in the 90s to early 2000s, and there's no VOCs found in that. We want to have another sample in that as confirmation, make sure that the deeper aquifer is not contaminated as well. There's ongoing vapor mitigation at the Water Gremlin building. In the interest of time, because I tend to ramble, I have deferred the vapor questions to a later time. There's an active subslab depressurization system going on at the building right now that captures the vapors before they can enter into the building footprint. That's going on right now, and then there will be additional remediation or mitigation if necessary. There's natural attenuation monitoring that we use for VOCs and groundwater when there's no imminent risk to human health or in the environment, when no one's drinking the water. That's that biodegradation, that breakdown, and reductive dechlorination of the material. That's just long-term monitoring, making sure it's not leaving the site, it's not changing, it's actually decreasing. You can put in a soil vapor extraction system, which they either are planning on doing or have doing on site here, that essentially pulls the vapors off of the groundwater, and since our VOCs want to be in the vapor rather than the liquid form, that expedites the process and helps break it down quicker. And there will likely be an environmental covenant on site, which is an institutional control that we use at the PCA a lot to prevent people from exposing themselves to the material that's hazardous on site. So, as we kind of indicated by the soil samples, there's a lot of lead below the soil or below the building itself. It is not feasible to expect them to destroy the building, dig out all that lead, and then rebuild everything on site. These environmental covenants will have restrictions that say, you can't do any soil work, excavation, drilling, digging, whatever on site without prior approval from the MPCA. We use these all the time when there's material left in place that's not an imminent risk to it. So those are our likely path forward on it. I know there's a question in the email about who pays for this. As a cooperative party-led, responsible party Superfund site on this, Water Gremlin is required to pay for all this investigation. They are paying the environmental consultants. They have to pay for the installation of the wells, the monitoring, the analytical results, all of that, and any mitigation is on them. This is not one of our state-listed Superfund sites where tax dollars go towards it. We'll do cost recovery for Tim and I's staff time when it's all said and done with as well. So, thank you. I know that was a lot of information to digest, but Tim and I are available for questions on this. We can take them now. You can email us later, whichever you guys would prefer.
Anybody have any questions for Mike and Tim?
You mentioned on some of these limits